All right, today let's try to solve number of islands in Python and then in C++. So it's been a long time since I've solved this one, and I want to see if I can still even do it in Python first. And then we'll try and see if we can translate that into C++, which I think will be probably a challenge because I haven't solved a problem of this difficulty before in C++ at least. So the idea is we are given an n by n grid, which represents a map of ones, which represent land, and zeros, which are water. And we want to count the number of islands. And the definition of island is that it is a group of ones that are connected vertically or horizontally, and all edges of the island are water. So in this example, we have one island because all of these ones are basically touching another one either horizontally or vertically, and all of the other cells are 0. And in this example, we have one island here, one island here, and one island here, so that's why their answer is 3. So we can solve this using a depth first search, and the idea is we will have a outer double for loop that will go through every cell in the grid one by one. And in the case that we find a cell that is 1, which is land, then before we move on to checking the next cell, we want to basically mark, we'll perform a depth first search from that cell that is a 1 and find all connected cells that are also 1, and we'll change them to be equal to 0 instead. So we're basically finding the bounds of the current island that we found. And the reason why we do that is because once we switch all of the adjacent ones to 0, then in our outer loop, when we move on to the next cell, we won't double count this island. So basically, whenever we find a 1, we're going to increment our island count. So we found the start of an island. We're going to sync all of the connected ones to it so that when we look at the next cell, we won't double count this island. So that should achieve the answer that we're looking for. And let's see if I can do this in Python. So I think that, let's see, we can start with the outer for loop. So I think we'll do something like for, okay, maybe we want to count the size of the grid first. So we'll say rows equals length of grid and columns equals length of the first row in the grid. And then we can say for row in rows and for call in calls, we'll say if grid at row column equals 1 as a string, then we will increment our count. So we'll have, we'll just say answer equals 0 for now. And then once we find a cell that is 1, then we'll increment answer. So answer plus equals 1. And then we need to perform our DFS on this row and column. And then I think at the end, we'll return our answer. And we need to implement our DFS function here. And I think that the DFS will probably return nothing. And let's see if this structure makes sense for now. So like I said, we are going to iterate through every single cell in the grid. Once we find a cell that is land, we know that we found the start of a new island, so we'll increment our counter. And then our DFS will sync all of the connected ones to this island, and then we'll just continue from there. So I think this part is correct, and now it's just up to us to implement the DFS. So how do we implement DFS? I think we need to have exit conditions. So I think we'll say if the current cell that we're at is out of bounds, we can immediately return. So let's say if not in bounds, we can return. And we can implement our inbounds function here. And we can simply say, we can return row is in range 0 to rows, and call is in range 0 to calls. I think that's a pretty simple way to check if we are in bounds. So basically, if our row is like -1, then we should return false. Uh, or if it's too large, then we're out of bounds in the like x direction, and same for columns. Yeah, that seems correct to me. So that will be one of our exit conditions, is if it's not in bounds. Um, Let me think about what else. I think if the current cell is a 0, then we don't need to do anything. So if grid at row and call equals 0, we can return. And I think we could also, we probably want to have a visited set so that we don't infinitely, we don't have an infinite loop. So we'll create a visited set. So we'll call it visited equals an empty set. And whenever we, I guess one of our exit conditions can be if not in bounds, or the tuple row call is in visited, then we will return. And then directly after that, we will add row and column to visited. So we can add the tuple row column, and then we can continue with our logic. So if the grid current cell is 0, we will return. Otherwise, if it's a 1, then we also want to recursively call DFS on this cell, and also change this cell to be 0. So we will say, I guess if we get to this point, then we know that the current cell is going to be a 1. So we can say grid at row call is now equal to 0. And then we'll say for all of our neighbors, our vertical and horizontal neighbors, we're going to recursively call DFS. So the way that I like to do that in Python is by defining a neighbors or like directions array. And inside of the array, we have tuples that look like this: 1, 0. Whoops, my key bindings are not working right. So we'll just do it this way. 1, 0, -1, 0, 0, 1, and 0, -1. And what this represents is um, the x and y deltas, like delta x and delta y, or delta row and delta column. So basically, like 1, 0 will be our row plus 1, and our column plus 0, which will be our neighbor to the right. This will be the neighbor to the left. This will be the neighbor above and below. Or I think that was flipped, maybe below and above. And the way that we use this array is we use a for loop here. So for dr and dc in dirs, what this is doing is unpacking the tuple so that we have dr and dc equal to like 1 and 0 for the first iteration of this loop. We will say new row, new call equals row plus dr and call plus dc. And what do we want to do? We want to call DFS on new row and new call. And I think this should be close to finished. Let's revisit our logic here. So the outer loop is going to look through every single cell. Once we find one that is a 1, we will increment our island count and then call DFS. Our DFS will say, it will exit out if we're at an invalid cell or one that we've already seen before. Add it to the current cell to the visited set. If the cell is equal to 0, we don't care. We can return. Otherwise, we will set the current cell equal to 0. And then for every neighbor, we will call DFS, which will do the same thing and return. So let's see. I think this should work. We have an error. Yes, this should be range rows, and this should be range calls. Okay, that took a while to run, but it looks like we got our 2 test cases correct. And let's try to submit it. Okay, seems like we got it correct. Our runtime doesn't seem to be the best solution, but I think this is good enough for now. And yeah, let's try to see if we can do it with C++ now. Okay, so I think this is going to be a little bit difficult because I don't even know how to use 2D vectors, to be honest. I think I know how to do it, but let's see if I can figure this out. So I think we can structure our solution in a similar way, and we will, let's say our answer will be 0 at first. Maybe we can find the number of rows and columns similarly to how we did it in Python. So we'll say rows equals grid.size. And I think we can say calls equals grid 0.size. Let's hope that works. Let's see. I guess we can use a unordered set. Is that what it's called? STD unordered set visited equals. Maybe we can just declare it like this. That's our visited set. And our outer for loop will be like this: for int row starting at 0, and then row is less than rows, increment row. We'll have the same for loop inside, which will be call. We want to say if grid at row call if it equals 1, then this is when we increment our answer. So we can say answer plus plus. And then we want to call our DFS. So we'll call DFS on row and call. So far, this solution seems pretty much identical to the Python one. So let me make sure we're doing this right. So we're going through every cell. We're finding every cell that is equal to 1. If it is, then we found the start of an island. Then we'll call DFS on this cell. And let's see, where do we want to return our answer? I think it will be out here. We want to return answer. And then all that's left is implementing our DFS. So we can say DFS, which takes in a row and column, and these will be integers, I guess. It's funny that I didn't even have to think about the type in Python. Our DFS will have the same boundary conditions, I guess. So we said if we're out of bounds or we've already visited. So we can say if not in bounds, and we'll pass in row and column. Or I'm not sure how to do something like a tuple. Maybe we can say this in visited. We can return. And I think I just realized we need to give this set a type. So what type are we going to store in here? we want something like a pair or a tuple, but I'm not really sure how to do that. Um, so maybe I'll just Google how to store like a pair in C++. This looks a little bit cumbersome, so I wonder if there's an easier solution. So we want to store row and column. Maybe we can just use a string. Yeah, maybe string will probably work. Um, so something like standard string, and inside of this set, we will say uh, maybe we'll format it like this. This is probably not ideal memory-wise or performance-wise, but maybe I can look that up after this and see if there's a better way of doing this. But anyway, so this is our boundary condition. So we also need to implement inbounds. Let's see if we can do that here. So inbounds will return a Boolean, and we'll call it inbounds. We'll take in a row and a column. And we will say, I'm not sure if there's an easy way to do it like we did it in Python, but maybe we'll do it the old-fashioned way. So if row is less than 0 or row is greater than rows, we can return false. And similarly for columns, we can do the same thing. Otherwise, we can return true. I think this should work. Or do we want to be greater than or equal to? Let's see. If our grid is 3 by 3 and rows equals 3, I think we want to, that would be out of bounds. So let's do it like that. And okay, so we have if we are out of bounds or we are already visited, then we want to return. And then we can add our cell to visited. So we can say visited dot, I forgot the method. I think it's insert. Yeah, I believe it's insert. So visited dot insert our string. How do you pass in variables to a string? Maybe we'll use standard format. Okay. And I think it was like this. We'll pass in our row and column. Is that correct? Format with the string with the template, pass in the two variables. That looks correct to me. And I think we need a parentheses here. Okay, so we just added our row and column to the visited set, and now we can, I think we wanted to check if the current cell is equal to 1 or 0. So if it's equal to 0, if grid at row and col equals 0, we can return out of this. Otherwise, we can set grid at row call equal to 0. And we want to call DFS on all of our neighbors. So for, I know there's a way to do what's called structured binding, I believe, which is like unpacking pairs in Python, but I do not remember the syntax. So let me think about the way I want to do every neighbor. Let's figure out how to do the structured binding method. Hopefully this question makes sense to Gemini. Yeah, this looks similar to what I was doing. So it says create an array or a vector of pairs. Let's see, for auto dx dy in dirs. Okay, so that's not too bad. This is creating an array, 2D array. All right, so I think it's basically the same thing. So we can say const int dirs, and it will be length 4 containing pairs. And the first pair will be 1 and 0. And then it will be -1 and 0, 0 and 1, 0 and -1. And we can say for auto, I guess, let's see the syntax. It's square bracket dx dy, but we can say dr dc in dirs. Hopefully this works. We'll say int new row equals row plus dr, int new call equals call plus dc, and we will call DFS on new row, new call. Oops. Okay. And I think that might be the full implementation. One thing I'm not actually sure is if we can even store a string inside of a visited set. I guess it needs to be hashable. In Python, strings are hashable because they're immutable, but I'm not sure if that is the case in C++. Let's just see if this runs, I guess. Okay, so we have an error. Yes, I forgot to give these types. These will be integer. Function declaration is not allowed here. Oh, okay. I guess we're not allowed to define functions inside of member functions. So we will create a different method inside of the class, I suppose. And that will probably be the case for the DFS. I guess we can pull that out and put it over here. We have an issue here with rows. Yeah, I think we need to make these member variables too. This set probably needs to be a global set. And I think that let's put all of our variables out in the outer class namespace. Grid is not defined. That is because we are passing in grid to num islands. So that is interesting. How do we want to handle this? I guess we could just declare rows and calls globally and set them inside of our function here. Um, Another issue, yeah, of course, because in is not an operator in C++. So I think it should be visited.contains. Let's see. Use of undeclared identifier grid, DFS. Okay, so maybe we could just pass in our grid into the DFS like this. And when we call DFS, we need to pass in grid because we are modifying it. And it's a reference, so we're changing the actual grid. And when we call it here, we need to pass in grid as well. Comparison of against a string literal is unspecified. So this is here, we are comparing pointer and an integer. So when we're accessing grid row column, I don't think that is a pointer. This is a vector storing a vector of characters. Maybe this needs to be a char. I kind of always forget about that notation. Not sure if that'll fix it. Okay, looks like that works. So yeah, for chars, we just use single quotes, and for a string, it will be double quotes. Let's see if submitting this will pass all the test cases. Okay, so it seems like we actually did pass. Our runtime is very slow compared to the bulk of these solutions, but I think that's pretty good for being a beginner C++ developer. Let's see if there's maybe some optimizations we can check out. So here they are using M and N as global member variables. Their DFS looks similar to mine. Set the current cell equal to 0, and then call DFS on the neighbors one by one here. M equals grid dot size. Pretty similar stuff to what I was doing. So I think in this case, when they're doing their boundary checks, they didn't define a separate Boolean function, which I'm guessing is probably making my solution less performant than this sort of thing. So I think that my solution is probably near optimal, but there's just some of these smaller optimizations that you can use to improve runtime by a small amount, unless I'm missing something large. But I think that's pretty good for today. The other thing I wanted to check was to see if there's a better way to store elements in the visited set. Let's see what they did here. Oh, they actually didn't use a visited set, it looks like. I wonder how they prevent cycles. Maybe the cycle detection is not necessary here because we are setting, we're setting cells equal to 0. So um, eventually the cell will equal 0 at some point, and then you will break out of the DFS. So maybe the visited set was not strictly necessary here. But in either case, I want to see if there's a easier way than storing strings in the visited set. So let me just quickly ask Gemini, is there a more idiomatic way to store pairs in a visited set, or is using a string fine? It says using standard format is a clever workaround, but it's non-idiomatic and expensive. Yeah, like I thought. So we're performing string allocations and formatting, which is slower than working with raw integers. So the node set approach is, since you're already modifying the grid, you actually don't need a visited set at all. So that's what I just figured out. Yeah, we don't really need a visited set. The other way is using a custom hash approach or a 2D Boolean array. So, okay. So we can create a Boolean array, and we'll just set the row column of that, or the cell in that array, equal to true or false, depending on whether we've visited or not. Let's see. Row call looks for the little string row and call. I guess I made a mistake somewhere here. Oh yeah. We would need to do standard format row call like this, and then this would be okay. So I guess that proves that my visited set is not even necessary. But we fixed that. But I think we can just delete this entire visited set anyway, and we can say if the cell is equal to 0, we can just return. And let's see if, I think we can delete our visited set here. And I think that should still work. I think we need to delete one of these. Oops, we don't need the visited insert again. Okay, so now with removing the visited set, we are more in the, I guess, acceptable range for performance for this solution. So yeah, definitely using the strings and visited set was not optimal, and the solution works as is without using a visited set. So overall thoughts, I think this is not too different from the Python solution. The overall idea is exactly the same, um, but I think we just got tripped up with using some of these semi-global variables or member variables inside of our num islands implementation. You can't actually define functions inside of a method, it looks like, so we have to put them out in the class namespace. What else? Yeah, I think everything is pretty much almost identical to the Python solution. So thanks for watching. If you guys have any questions, leave it in the comments below. If you like the video, give me a like, subscribe, and see you next time.